My name is Daniel. I'm one of the maintainers of Cortex. And I want to try something different here. I'm going to try to dive deep in one of the problems that we have. We have a bunch of challenges in Cortex. I want to see if you guys get interested in what we are doing there. Just an overview, because I want to talk about Cortex and what we do. Cortex, I don't know how much of you guys are familiar with Prometheus. Prometheus is a very well-known CNSF project for handling metrics. It has an ingestion metrics. It has a query metrics that you can use from QL. And Cortex is basically a scalable Prometheus. That's what we are trying to achieve. We have high availability, we have multi-tenants, and we have long-term storage in Cortex, which on top of Prometheus. We actually use Prometheus a lot as engine for ourselves. So how does Cortex works? And that's maybe be a bunch, but what we try to do is we split Prometheus in a lot of microservices. So we have a bunch of microservices for each type of request that you are doing. I want to focus here in the remote write path, which is basically the remote write for Prometheus. So in Cortex, we have main two microservices for that area, which we call distributor and ingesters. The distributor is basically a proxy. You can take a look at as that. It receives a request, it shards the information, and inside two ingesters. The ingester is normally a fleet. When you're talking about fleets, we are saying that a cluster Cortex can receive 500 millions, 1 billion time series. So it's a huge ingester to receive this data. And it basically is a storage layer. So it's receive the data and put it on disk. And the way that they communicate is using this ring, which is in the middle, like the circle thing. So what happens is, ingester, when it joins, it puts itself in the ring. Distributor looks at the ring and knows where to send the data. So how this ring looks like? So right now we use tokens in the ring. So when ingester is starting, we add tokens for it. We generate random tokens for that ingesters. Let's say in token 4 here. And ingesters 1 itself adds itself to the ring. And it basically owns that part of the ring. That's basically how it works. And when distributor receives the information, it hashes that information. With that hash, it looks at the ring to see which ingester should receive that information. So let's say that you have hash 3. That information goes to ingester 1, and so on and so forth. So how a request actually works for Cortex. A request has multiple samples, time series, whatever you want to call it. It's actually different, but let's call time series here. And we shard each information by time series. So the idea is you receive a request with 1,000, 5,000 time series, depends on how you are sending it. And each time series is sharded for 3 ingesters in this case, because we are using a replication factor of 3. So we have to have 2 out of 3 for a success result. And this information here creates this mesh. So we have each one going to 3 random ingesters, which works fine for us. But the problem comes when we have 2 ingesters down, for example. So if there's 2 ingesters down and 1 information is going from these ingesters, we basically have a failed request. Even though it's just one time series inside of the request that's failing, we have to reply as a failed request because we can't confirm that 2 out of 3 has that information. The problem here with this token approach is when we are talking about a cluster with 500 million time series, which a request comes with 5,000 time series, and we have 1,000 ingesters, this comes basically to 100% downtime with us. If we have 2 ingesters down. The chances of one time series going to 2 ingesters is pretty much 100%. And that brings our fleet to 100% down. So how do we try to solve this? So we are adding this idea of partitions. So now, when you look at the ring, the ingester doesn't have tokens in the ring anymore. The idea is the partitions itself has tokens in the ring, and the ingester joins a partition. So when you think about partition 1, it actually has a token 4, and it's actually receiving that data. So how does request look like now? So if you look at the request for a request that we are seeing before, now the time series is actually for a partition, and that information is sent to the same 3 ingesters every time. So we stop with that mesh that we had before, and now we have a pretty cool thing for us, which is a replication of data between AZs. So we know exactly where this information is going for. And why this is so good for us on terms of availability, and that's what we are trying to do with Cortex, is if we have 2 ingesters down, let's say ingester 2 and less than 3, doesn't matter which AZ, they are not impacting us because we know that partition 2 still have 2 out of 3, and partition 3 still have 2 out of 3. So the only impact that we have is when we have 2 ingesters down in the same AZ. And what's the results from it, what's the numbers. So I tried to do some math. I hope that's correct. But in the current approach, if you have 2 failed ingesters, as I said before, it's basically 100% chances of downtime. In the new approach, in partition approach, if you look at 10 partitions, a cluster of 10 partitions, it's basically 10% of chance of going down. So, and what's neat about this is with scale, and that's the idea of Cortex, when you're scaling Prometheus, when you start to add partitions, when you start to add ingesters, your chances of going down actually decreases a lot because you have more ingesters. The chance of they being the same partition decreases a lot. So that's pretty cool for us. That's a huge achievement for us. So how about Cortex now? A little bit more. We are just releasing today version 1.20. There's a bunch of cool stuff there. We are trying to get in touch with Prometheus 3.0, so we are supporting remote write v2. There's Parquet format, which the community is working a lot against it, about it. It's super cool to speed up queries and latency for it. And I hope you guys like it, what I showed, what the challenge that we are working on. And if you guys want to talk to us, there's a bunch of channels that you can reach out, and we're going to have also a kiosk in the Pavilion tomorrow and Wednesday. Thank you very much.